All right, 1.2, the defining moment. 1. The images show some line segments that are chords and sub-segments that are not chords. So these first three here are all considered chords, and then these next three down here are not considered chords. So based off this diagram, I want you to try and give it a shot and write what you think the definition of a chord is. Okay, well hopefully whether or not you saw any differences between the two diagrams, you should at least notice that they're talking about a line segment. So that's the first part of what we're gonna talk about for the definition here. So it's gonna be a line segment. All right, when we talk about a line segment, we talk about something that has two endpoints, right? We can see here, they'll have dots at the end, so we know they're finite, they don't go on forever. So when we look at the two endpoints, they always end up somewhere on the circumference, right? Circumference, that's just the perimeter of a circle. So the starting point and ending point must both be somewhere on the circumference. Here, nowhere on the circumference. Here, the center and the circumference. So the center is not part of the circumference. It's very different. All right, even in our formula for a circle, x minus h squared plus y minus k squared equals r squared, h and k would be the coordinates of the center, and then anything you plug in for x and y that make the equation true would be anything on the circumference. And here it doesn't touch the circumference quite. So it's just a line segment connecting two different points. On a circle's circumference. All right, and I say two different points because if you connect it to the same point, it would really just like be a dot connecting to itself. We really wouldn't call that a chord. Okay. On to number 2. All right. The images, whatever. I can kind of see the background, but I think you guys can see it pretty clearly. The images show some highlighted objects that are arcs and some highlighted objects that are not arcs. So very clearly, this is not even on a circle. So, I mean, we would call this more of a curve, I suppose, or it looks like it's part of a parabola. And here we've got a line segment. So these we would definitely not call line segments because they are curved. They're segments, but they're not line segments. So they definitely are always somewhere on the circle's circumference. So an arc we define as, well, actually, try and define it on your own first. Okay, so the way we're going to define an arc, and I'll take a look at your definitions, and maybe I see something that I really like, and we can talk about that in our meeting Wednesday. A portion of a circle's circumference. Actually, I don't want to use the word portion. I want to use the word segment. All right. Can be minor or major. Oh, I can't spell today. So what do I mean when I say minor or major? Well, to really drive home this point, I think it'd be helpful if I got out a highlighter. So if we look here, if I tell you that, let's say this is A and B, right? So I'm talking about arc AB. You might not know exactly what I'm talking about. Am I talking about this arc AB, or am I talking about that arc AB? So one way some people sometimes differentiate these is calling it the minor and major arc. So here the smaller one would be the minor arc. And the green, the larger one, that would be the major arc. It's funny they use the words minor and major. Those are words, if you've ever played a musical instrument, you have minor keys and major keys. And we just talked about chords. You can have minor chords and major chords in music as well. So math and music are actually quite interconnected. Another way that I tend to use also to differentiate is I'll like throw on another point, like let's call this C. So I can say, and I'll give you also the notation for an arc. I might say arc A, C, B, like that. See how it's got a little sort of curve on the top? That lets them know that I'm going from A to C to B. If I'm talking about this one, I might just call it arc AB or BA. Right, order, like an angle, doesn't really matter. I can call it this also BCA. All right. If I'm talking about the length of an arc, we put like just a little m in the front. To measure arc AB, just like you would for an angle. And you'll find that there are actually quite a few similarities between arcs and angles. Okay, great. Yeah, that's all I want to talk about with arcs. All right, number 3. The images show some angles that are central angles and some that are not. So up here, we've got 3 angles. They all seem to be touching that center. And here we've got some other types of angles. Some we will deal with, some we will not deal with this year. So try right now, looking at these pictures, how would you define a central angle if these are central and these are not? Well, we'll notice that the vertex for the central angle must be the center of a circle. So that's really how we're going to define this. An angle whose vertex is the center of a circle. Yeah, that's really only way we're gonna use to define this. Normally, I mean, you wouldn't see like the segments like continue forever, but there could be a complex diagram where that happens, and this would still be a central angle, regardless of how long these are. But normally, we see them subtend to the perimeter or the circumference. What do I mean subtend? So if we see we have a central angle here, this central angle subtends this arc right here. It intercepts might be another word that you're more familiar with. So let's say I'm going to call this A, B, C. We would say that central angle, oh, I just broke my pencil. Pushing down too hard. Central angle CBA subtends, or if that word is throwing you off, you can also use the word intercepts, arc AC. I know those, I should have really, see if I can fit that in there. Looks a little odd when I write like that. All right, this central angle is going to subtend this arc right here. And as we move on the unit, you'll see that there's a very close relationship between angles and the arcs that they subtend. Most of the time there is. Yeah. Another thing you might notice is that really when we have a central angle, there are technically 2 central angles, right? Technically you could say that this angle right here, right? We call this the reflex angle. Is also a central angle. Normally in this class we're going to deal with acute angles. It's rare that we're going to deal with the reflex angle, which is usually it's way more than an obtuse angle. It's above 180 degrees, right? If this, let's say this was 90, this would be 270. We don't really deal with angles like that, so we usually stick with the acute or obtuse angle. you might have here. So actually, I'm sorry, this looks like it probably is obtuse. Looks like it's a little bit more than 90. So I would say the smaller angle of the central angle. I guess you could call it the minor angle, maybe. I've never really heard that term. But we're much more likely to deal with that. Okay, that's all for 1.2.